In the previous session, we looked at the definition of molarity and discussed the basic idea of molarity calculations. Let's look at a few problems that involve molarity. So here's a problem where we are asked to calculate concentration of a solution that is made by dissolving 1.550 grams of sodium nitrate to make 500.0 mLs of the solution. Now, since the only unit of concentration that we are discussing so far is molarity, when you see concentration, that's what we need to think about. So if you remember from previous session, that molarity is defined as moles of solute divided by liters of solution. Do we know what is the solute in this case? Yes, the solute is sodium nitrate. Do we know the moles of sodium nitrate? No, we don't. We have the mass of sodium nitrate given. Can we convert mass, grams of sodium nitrate, to moles? Absolutely, we can, using the molar mass of sodium nitrate. What do we need to know to determine the molar mass of any substance? We need to know the correct chemical formula. It is very important. If you're not sure of that, you must go back and learn that again before you go any more. Okay, so the correct formula for sodium nitrate, of course, is NaNO3. So we can convert 1.550 grams of NaNO3 to moles of NaNO3 using molar mass, which calculates out to be 85.00 grams. This gives us 0.018235 moles of NaNO3. Please note I'm not rounding at this stage because this is not my final answer. We are given mLs of solution, so 500.0 mLs will need to be converted into liters by using the appropriate conversion factor, which says 1 liter equals 1000 mLs. That gives us liters. Okay, now we are ready to use the formula for calculation of molarity, which says moles of solute, which we calculated out to be 0.018235294 moles of sodium nitrate, that's the solute, divided by liters of solution. That gives us, please note, moles per liter, that's molarity, and this upon calculation gives us 0.3647059 moles per liter. Moles per liter can also be written as molar, uppercase M. This needs to be rounded to 4 significant figures, and therefore 0.03647 molar. You could leave the answer as that, or you could express it as in scientific notation 3.647 times 10 raised to minus 2 molar. That's totally up to you. Okay, please go ahead, look at the next problem, pause the recording while you attempt the next problem on your own. So in the next problem, it's very similar to the one that we already did before. We know that in this case, the solvent is water and the solute is glucose, and the chemical formula is given. If you calculate its molar mass, it comes out to be 180.18 grams per mole. So molarity is moles of solute divided by volume of solution. We are also given the volume of the solution. So we can convert 1.255 grams of glucose, C6H12O6. We can convert that to moles of glucose by using the molar mass. And then moles of glucose can be divided by volume of the solution, which in this case is 1.50 gallon. Now please remember, molarity is moles per liter. We have gallons, which means basically that we need to convert gallons to liters. Gallons, 1 gallon contains 3.785 liters. Now, what I would really like for you to, I'm hoping that you would recognize that at this stage, the unit we have is moles of solute divided by liters of solution, which is nothing but molarity. So we are on the right track. When you complete this calculation, we get 0.001226818 moles per liter, or you can, instead of writing that, you could just write molar. This needs to be rounded to 3 significant figures because of the gallons right there. So this gets rounded to 0.00123 molar. Of course, you could also write it as scientific notation 1.23 times 10 raised to minus 3 molar. Either answer is correct. Okay, the next problem is similar, except that in this case, instead of asking us to calculate concentration, they're asking us to calculate the mass of the solute given the volume of the solution and given the molarity of the solution. Now, if molarity equals moles divided by liters volume, we're given molarity. In this case, we know the volume. Of course, the volume is given in mLs, not in liters, but we can convert it into liters. The only thing we do not know at this stage is moles. Can we rearrange this formula for moles? Absolutely. Moles will then be equal to molarity times volume in liters. Can moles be then converted into mass of the solute? Absolutely. We've done it many times by now. Okay, so before we start setting up the problem, one more thing. What is calcium 2 sulfate? You will need that at some stage. Correct chemical formula for copper 2 sulfate is CuSO4, so you will need its molar mass at some point in time. So let's set it up. Let's start with the molarity given as 2.55 molar means 2.55 moles of solute, which is copper 2 sulfate in this case, for every 1 liter of solution. That's what molarity means. If this were multiplied by volume, which is given as 150 mLs, we cannot yet cross out anything because mLs and liters can't be. But we can definitely convert mLs to liters, remembering that 1 liter equals 1000 milliliters. Notice that at this point, liters are crossed out, mLs are crossed out. The only thing that we are left with is moles of the solute. Moles of the solute, of course, 1 mole of copper 2 sulfate can be converted into grams of copper 2 sulfate by using molar mass, which calculates out to be 159.61 grams. So moles cross out. Question, of course, is asking us for mass in kilograms, so grams will need to be converted into kilograms. 1 kilogram equals 1000 grams. Calculating this gives us an answer of 0.061050825 kilograms of copper 2 sulfate. This answer needs to be rounded to 3 significant figures, therefore 0.0611 kilograms of the solute copper 2 sulfate. Okay, please go ahead. Take a few minutes, pause the recording, read the problem, and set it up. So in this problem, we are asked to calculate the volume of a solution whose concentration is given and the mass of solute is given. So, first of all, if molarity equals moles divided by volume liters of solution, can we rearrange this equation for volume? Exactly that, then volume in liters will be equal to moles divided by molarity. Do we know molarity in this case? Yes, we are given molarity. Do we know moles in this case? No, not quite yet because we're not given that, but we can figure it out from the mass of the solute. So what is the chemical formula for magnesium chloride? Magnesium chloride is MgCl2. Okay, so let's get started. So we know we have 1.050 pounds of magnesium chloride. First step is pounds needs to be converted into grams. 1 pound equals 453.6 grams. Once you know grams of magnesium chloride, that can be converted into moles of magnesium chloride using molar mass of magnesium chloride, which calculates out to be 95.21 grams. Moles of magnesium chloride divided by the molarity gives us volume. So please watch how I'm placing these units of molarity. Molarity is moles divided by liters. So moles manganese solute at the bottom, cross out, liters on the top, which means there are 1.25 moles of solute in 1 liter of solution. When you calculate this, we get 4.00193257 liters. That needs to be rounded to 3 significant figures, gives us 4.00 liters of this concentration solution that will contain 1.050 pounds of magnesium chloride. Okay, the next problem is very similar, and I would like for you to once again pause the recording while you read the problem and set it up. So in this problem, the solute is ethyl alcohol. The solution's concentration is given and the volume of the solute is given. See, please notice it's not the volume of the solution, it's the volume of the solute. But why do we need volume of the solute? Now, if you know the volume of a compound and you know its density, can you calculate the mass of the compound? Exactly, you can. From the mass of the compound, can you figure out moles of the compound? And then the rest of it. Exactly. So let's start this process. We know that we have 5.50 mLs of ethyl alcohol. That's the solute, it's not a solution. C2H5OH. Oh, excuse me, that's not liters, that's mLs of ethyl alcohol. Please remember, cc and mLs are equal to each other. So if I use density, which says there is 1.065 grams of ethyl alcohol in 1 cc, cc and mLs being equal to each other, cross out. What I have now is grams of the solute. Grams of solute can be converted into moles of solute using molar mass of ethyl alcohol, that is 46.08 grams. Moles of ethyl alcohol can then be converted into volume of the solution using the molarity, because there are 0.837 moles of solute, that is ethyl alcohol in this case, in 1 liter of solution. So at the end of this whole process, we have the volume in liters. When you calculate this, we get 0.151870,831 liters. This rounded to 3 significant figures gives us 0.152 liters of the solution. Okay, once again, please pause the recording while you read this problem and try to figure out the setup. So in this problem, we are working with a solution of acetic acid. So once we need to know what acetic acid is. Acetic acid formula is HC2H3O2. We are asked to calculate pounds of acetic acid will be dissolved if in a solution of volume 1.00 gallons and the concentration 0.8041 molar. So pounds meaning mass. Mass can be obtained from moles and moles can be obtained from molarity and volume. So molarity being 0.8041 molar means that there are 0.8041 moles of acetic acid in 1 liter of solution. If this is multiplied by the volume given 1.00 gallons, you can't yet cancel out anything. But gallons can be converted into liters because 1 gallon contains 3.785 liters. Please notice, liters crossed out, gallons crossed out, leaving us just with moles of acetic acid. Moles of acetic acid can be now converted into grams of acetic acid by using molar mass. Molar mass of acetic acid is calculated out to be 60.06 grams. And since the question is specifically asking for pounds, grams will need to be converted into pounds, which 1 pound is equal to 453.6 grams. Please, when you go through this setup, follow each conversion factor and make sure you understand the purpose of each conversion factor. Upon calculation, this gives us 0.402984394 pounds of acetic acid. This needs to be rounded to 3 significant figures because of the gallons, and that gives us an answer of 0.403 pounds of acetic acid.